Hello, algebra students. We're going to look at inverse functions again, and we'll be finding the inverse of some functions and then graphing both the function and the inverse. But first, I just want to look at another example of a function that's just made up of four ordered pairs and its inverse, and just talk about this from a little bit different point of view than we did the other day. So here's our function. This one's called g. So you have it in a table form where you have x and g of x. The x's are the input values. The g of x column gives the output values. And we also have its inverse over here. Okay, so its inverse is we write g to the negative 1. And I was reading that like g to the negative 1 the other day. A better way to read it is g inverse. You write it like g to the negative 1, but we should read it g inverse. So we see that when you have the function g has an input of 1 and an output of 2, the g inverse function, taking that same output of 2 and using it as an input for g inverse, gives you an output of 1. Okay, and next example, the next point, you have, if you use 3 as an input for g, you get out 6, but if you use that 6 as an input for g inverse, you get output of 3. So notice it's the inverse function undoes the function, you might say. It gets you back to the original input value. See, we started with 3, we get out of 6, we take that 6 and put it into the inverse, we get the 3 back that we started with. So you could say in general, if you have a function f and if an input of a results in an output of b from that function f, then if you take that b and use it as the input to the function f inverse, what's your output going to be? It will be a. Okay, so the same a went into f. You got some output. Use that output as the input to f inverse. You'll get a back again. And some people say if function f turns an apple into a banana, then f inverse turns the banana back into an apple. Okay, so let's look at some functions that we're going to find the inverse of each function. And we have them right here. And we're going to graph, in each case, the function and its inverse. So let's look at the first one. F of x equals negative 5x minus 2. So the first step is to replace f of x with y. And y and f of x are two different ways of saying the output of the function, right? So you can write either one. They're interchangeable. So it's more convenient, though, to use y. So we're going to use y in place of f of x. And next step is to swap the x and the y. So when you see y, you write x. When you see x, you write y. And then this could be thought of as the inverse function already, in the sense that we could use this to get an output value for any x that we plug in. We could plug in the number 2, for example, for x, and then we could solve this for y. We would have to solve it, right? Because y is not by itself on one side of the equation. But once we solved it, we would have our output. We could put in 0 for x and solve for y. For any number we want to put in for x, we could solve for y, and that would be our output. But to say that we've really found the inverse, we want to actually have y by itself on one side of the equal sign so that we can plug in for x and calculate y without having to solve for y each time. So that's what we're going to do. We solve for this for y, get y by itself. First thing to do is add 2 to both sides to get rid of that negative 2 on the left. So we have x plus 2. I'm sorry, to get rid of negative 2 on the right. We have x plus 2 on the left. We have negative 5y on the right. Now we divide both sides by negative 5. And so to do that, we'll divide each term on the left by negative 5. And on the right, divide by negative 5, and of course it cancels there. And on this next step, I'm going to go ahead and rewrite this x over negative 5 is the same thing as negative 1/5 times x. And then 2 over negative 5 is the same as saying minus 2 over 5. And then on the right, all we have is y. We'll just switch sides so that y is on the left. And that is our inverse function. We've solved for y and we have our inverse function. We will, as the final step, write that as f inverse of x, because that's what it is. And just rewrite it. And that's it. Okay, let's do the next one. So first step, replace f of x with just y. And then we're going to swap x and y. So when we see y, we write x, and where we see x, we write y. Now we want to solve for y. So first subtract 3 from both sides. Have x minus 3 on the left. On the right, we have 1/2 times y. Now, we want to get rid of this 1/2. How do we do that? It's a fraction. Multiply both sides by its reciprocal. So, multiply, the reciprocal of 1/2 is 2. Multiply the left by 2. Multiply the right by 2. And so on the left, you just distribute. On the right, it does cancel and just leaves us with y. And we've got it. We'll turn it around and put y on the left. And then we will replace y with f inverse of x. As y was the y that we found here. Once we solve for y, that is f inverse of x. So that's it. Okay, one more. Okay, so first replace f of x with y. And now we swap the x and the y. So when we see y, we write x. When we see x, we write y. And now solve for y. So we have to add 1 to both sides first. Have x plus 1, and on the right we got rid of the 1, so the negative 1, so it's just y squared. Now we want y by itself, but we have to get rid of that exponent. Well, squaring and square root are inverses of each other, so we take the square root of y squared, we'll get y. So on the left, so we have to take the square root of both sides, of course. You can't just take the square root of the right side. So square root of the left is square root of x plus 1. And on the right, we take the square root of y squared. And square root of y squared is y. So the square root of anything squared, of course, is just the anything. In this case, it's y. So that's it. And we'll go ahead and turn this around. Put y on the left. And replace y with f inverse of x. Okay, so we've got all three of them, and now we're going to graph them. Okay, so let's look at that. I'm using the online graphing calculator, desmos.com. It's pretty slick. And to save time for the video, I've already typed them in. So over here we see the original function was negative 5x minus 2. The inverse was negative 1/5 x minus 2/5. So I can just click this to make that visible. That's the original function. That's the inverse. And I'm also going to show the line y equals x, and I've got it dashed. So that shows that the original function, which is in red, if you rotate it around the line y equals x, rotate it around, so to speak, you get the inverse, which is the green one. Okay? So let's go ahead and take those off and look at the next one, which was 1/2 x plus 3. And the inverse is below 2x minus 6. And I'll leave the line, the dashed line in there, y equals x. Okay, so the original function, there it is in black. The inverse, 2x minus 6, is in red. We'll zoom out a little bit so we can see it all a little bit better. And there it is. Again, you can see the way they're sort of reflections of each other off that line y equals x. Or you could say you rotate the function around the line y equals x and you get its inverse. Okay, so let's look at the last one. The original function, y equals x squared minus 1. Zoom in on it a little bit. There it is. It's a parabola. Now its inverse is, we said, is the square root of x plus 1, but really, and you don't have to worry about this too much, but when you take that square root of both sides, the radical symbol itself, as we have here, just means the positive square root. There's also a negative square root. of any positive number, right? So we could say the square root of 4 is 2, but, well, there's also negative 2, because negative 2 times itself is positive 4, right? So if you're talking about the square root of a number, let's say 4, it has two of them. For example, 4 has 2 as a square root. Also, negative 2 is the square root of 4. And again, you don't have to worry about that a lot, but the point is there's a positive and a negative, and so I have them both here. This is the positive square root, and I made them the same color. There's the negative. And so if we show both the positive and the negative on the graph, that's the green. And the blue was the original function, and there it is. Again, they're reflecting, or let's say rotate. You could think of it either way. Rotate the original function around the line y equals x, and you get the inverse. Now notice the inverse, if we do the plus or minus like I did, the inverse is not a function, right? It fails the vertical line test. And sometimes that's the case. Okay, so that's all. That we just had those three. Hopefully looking at the graphs is kind of interesting and helps us understand it a little better.